It's the delta math I assigned this morning. Like it's, I think I called it solving trig equations. All right, so we are picking up where we left off yesterday, which we are on the back of the unit 7, or excuse me, unit 3, part 7, the supplemental notes sheet that I passed out yesterday. We are on the back, which is using factoring. And so we have these bottom two in the section that says together. Okay. So in this one, this looks similar to the last one we did yesterday. Let's scroll back up here. See how this was a cosine squared, cosine, and then a constant? It was a trinomial quadratic form. This looks very similar to that, but something slightly different. Do y'all notice it? It's sine squared and then cosine. So these don't match, right? They're not the same function. So that's like having two different variables. That's like having an x squared and then a y instead of an x in that next term. Okay, so we can't do that quadratic form factoring yet the way that it's written. So we need to think back to the first half of unit 3, the one that we tested on last week. Is there something that I could replace? Oops, I don't want that to be solid. That I could replace sine squared of t with to put it in terms of cosine? Remember all the identities we talked about? Is there an identity that puts sine and cosine together? There is one. Do you remember what type of identity? A Pythagorean identity. Does anybody remember what the Pythagorean identity was? It was sine squared plus cosine squared equals 1, right? So if I need to rearrange that to know what sine squared is equivalent to, that means the cosine squared got subtracted over to the other side. So it's 1 minus cosine squared of t. Okay, so I'm going to make that substitution. Okay, those two highlighted in pink are equivalent to each other because of the Pythagorean ID. Does that make sense? Now, everything else there stays the same. There's still a 2 in front of it. There's still minus cosine t minus 1. That's still equal to 0. Now it's not, now I've got it all in terms of cosine, so that's a start, but it's not ready to be factored yet. It's not in that ax squared plus bx plus c form. So I'm going to distribute this 2 to get rid of these parentheses. Okay, now I've got a couple of like terms that I can combine, the constants there. So I've got negative 2 cosine squared of t minus cosine of t, and then 2 minus 1, so that's just plus 1. So far, so good? So now it's to the quadratic form trinomial. However, you probably learned this back in maybe algebra 1, but algebra 2. When you are factoring, it is much easier to do factoring if your a value is positive, right? So let's make it easier on ourselves and change this to a positive. How could I change this to a positive? Okay, so I heard that way. What did you say? All right, so I heard 2 ways we could do it. They're both correct. Okay, so one way is we could add it to the other side and become positive if we moved it over here, right? We just need to move everything. But if we move everything to the opposite side, what happens? All of their signs change, right? Okay, would the same thing happen if I just divided everything by -1? It would. Dividing by -1 wouldn't change any numbers. I would just change the signs. And as long as I do to one side what I do to the other, I can do that. And what would happen to the 0 if I divided by a -1? Stays 0. Okay, so whichever one of those methods makes more sense to you, it comes out the same. All of the signs end up changing. Okay, so I'm just going to rewrite it with all opposite signs. So this is now positive. This one is positive. This one is negative. 0 stays 0. Okay, so right here, I just divide out the negative. That's what I did here. But I had to do it to all the terms, the entire equation, both sides. Now it's ready to be factored. Okay, so trinomial factoring. I know I'm going to factor it into 2 sets of binomials. There are multiple methods for doing your factoring. Okay, so remember your A value, the A term, I should say, right here. What are the only factors of 2? 1 and 2, right? Yeah, it's prime. Okay, the only factors of cosine squared would be cosine times cosine, right? Okay, so that's going to split to 2 cosine and 1 cosine. Those are the only factors of this. Okay, so I'm not actually going to go through and do grouping or box method or slide divide or any of those methods we reviewed on factoring earlier this week. Because this is a prime number, I think it's relatively easy. I'm just going to go ahead and do the guess and check method because it's not actually going to take long because 2 is a prime number. Okay, so we got those factors pretty easy. And then C is also a prime number. What are the only factors of 1? 1 and 1. So I know the numbers. I know what the numbers are. The only thing I have to think about is, do I put a plus or a minus? Okay, so I do need to think about the fact that it multiplies to a -1 for C means that one of these has to be negative. They have to be opposite signs, right? And remember, to get the middle term, this is an understood 1 right here. Okay, so I want it to multiply to a -1. Okay, but when I do the foiling, the outer and the inner, and then add those, I want it to add to a positive. So that means this one over here that gets multiplied by the 2, that needs to be the positive 1. And this one can be the -1 because it just gets multiplied by 1 cosine. So we'd end up with 2 cosine minus 1 cosine, and that would be 1 cosine, right? Okay. So the only thing I really had to think about in that one was which one was plus, which one was minus. You okay with that? If you prefer to do the all-out box method, grouping, whatever, even when those are prime numbers, that's fine, you can. I just think this was a little quicker. All right, once you have your function or your trig function separated into separate factors, you're ready to split and solve. So I'm going to set this side equal to 0 and this side. And I'm going to solve them each individually. So when I solve this left side, I have to add the 1. And then divide out the 2. So I have cosine of t equals positive 1/2. So I am asking myself, where on the unit circle, you can use your unit circle, you don't have to have it memorized, where is cosine positive 1/2? Well, cosine is positive in 1 and 4, right? So I know my answers are coming from these 2 quadrants. So you can look and find, remember, cosine corresponds to the x value. Look and see at what angles the x is 1/2. Or if you have your reference angles memorized, you should know that cosine is 1/2 at pi thirds or 60 degrees. So it's the pi thirds angle in these two quadrants. So in quadrant 1, that's just pi thirds. And in quadrant 4, it's 5 pi thirds. So those are two of the solutions from this factor. Now let's see if there's any solutions from this factor. Remember, not every factor will give a solution every time. Remember yesterday when we did this one and this factor, that could not equal 4. No solution because 4 was outside of cosine's range. Okay, so we have to check and see, is there another solution or not? So I'm going to subtract the 1 over. So I have cosine of t equals -1. So I'm asking myself, where on the unit circle is cosine -1? Where's the x -1? Yeah, that's on the x-axis, the left side of the unit circle, that point. Okay, and that angle is pi radians. So we're giving our answers in radians. So this had 3 solutions in all. You good? Okay. All right, one more on this section. I'll start to finish writing. Okay. Here, we're in the same boat because we have 2 different trig functions again. If you have 2 different trig functions, you have to get everything to one side set equal to 0, which that's already done. It's set equal to 0. And then either factor, if it's able to be factored by GCF or trinomial factoring or difference of 2 squares, whatever. Or if you can't factor it, there's no way to factor it right now, see if you can think of identities you could use to make some substitutions like we did over here. Okay. Is there an identity that puts tangent and secant together? Hopefully y'all have that sheet we did a few weeks ago where we had all the identities on one page that I told you filled in when we did that matching activity. You can look there. Any of those identities put tangent and secant together. I'll pull up my list of all the identities and put it up on the screen if you don't have yours to look at. Here we go. Here's our identities. We have reciprocal identities, quotient identities, cofunction, odd, even, and Pythagorean. Is there any identity that has secant and tangent in the same one? This one right here. 1 plus tangent squared equals secant squared. So I can replace secant squared with 1 plus tangent squared. And then everything, the only functions are all tangent at least, right? Okay, so that's the strategy we're going to use. We're going to try that out. No, because this one is just tangent, not tangent squared. So I wouldn't have been able to replace that one with the same identity. All right. What you think we do next? Does it look like it's in quadratic form, like trinomial yet? Okay, same thing we did over here. We distributed that 2. Here it's an understood 1, but it's negative. So we have to distribute that -1 to both of those terms. So we'll have 2 tangent of x minus 1 minus tangent squared of x. Still equal to 0. But I'm in the same boat here now as I was over here with that, the squared term was negative. Our squared term is negative. We don't want that. So I do want to change all the signs again. Okay, but in the same step, I'm also going to just rearrange these. We want to have highest degree to lowest. So I want to have the tangent squared term first, and then the tangent term, and then the constant, right? Okay, so I'm going to divide out the negative and put those in the correct order. So that's going to be tangent squared of x is a positive, and then the 2 tangent of x will become negative, and the -1 will become +1, and the 0 doesn't change signs because it doesn't have a sign. Still 0. Now it's ready to be factored. Now we're to this same point we were over here. Okay, so when I go to set this factoring up, this is another one. The A is an understood 1. So I'm not going to worry about doing grouping, box method, slide divide, any of that. I know the only factors of tangent squared will be tangent times tangent, right? It's just like if it was x squared, you would split it to x and x. Okay. So I know I just need to ask myself what multiplies to 1, but adds to -2. So it needs to multiply to a positive and add to a negative. So they both must be negative, right? And it's just ones. The only factors are 1, right? Wouldn't -1 times -1 be +1? -1 plus -1 is -2. Okay, so that one's even a little easier because we didn't have that 2 in front to worry about. So now we're ready to split and solve, but what do you notice? They are identical. There is no need to solve it twice. I would hope you get the exact same answer twice, right? So just worry about doing it once. Set it equal to 0, and we're going to solve. So we are now on our unit circle asking ourselves, where is tangent 1? Okay, what quadrants is tangent positive in? 1 and 3. So I know I'm going to have answers from these 2 quadrants. At which reference angle is tangent 1? Pi fourths, or 45 degrees, right in the middle, right? So at quadrant 1, that's pi fourths, and the pi fourths angle in quadrant 3 is, good, 5 pi fourths. Awesome. How y'all feeling about these? The ones where you're factoring, those are a little tougher, I know. They take several steps. It's a long problem. Time, be careful. Okay. All right, there are 2 more down there at the bottom that say with your partner. If you, oops, sorry, I go too fast. That's okay. Good. All right, so there's 2 that say with your partner. So I want you to try those either with your neighbor, y'all, or people around you. Y'all can discuss and work through it together, strategize, okay? Or you can work it on your own, and then we're going to go over it together in about 5 minutes, okay? If you're watching this on video, you can just pause your screen, try it on your own, and then come back to the video to check. Those of you in class, I'm just going to freeze the screen and go ahead and be writing it out for y'all to check when y'all are done. Not both of these are not factoring. Remember, you don't always have to factor. Factoring is a strategy if you have more than one trig function there. Okay, that second one, there's only one trig function term, so you don't have to factor that one. Little hint there.
It has two signs.
No, actually, it wasn't. Yeah, you're. How big was you?
This is a problem.
Yeah, he's ate the seed. Yeah, because he told me that he's the spicy part, so I ate the spicy part.
It's been with her.
Give me a pretty big piece, right?
Huh? He said to me. Oh, that's he said, oh,
Sure. Well, it won't necessarily, it won't add to -1 on its own because that 2 is out there. So the one that gets multiplied by, it would have to, one of them would have to be multiplied by the 2 first. I'm recording. All right, we're going to come back together. I'm going to unfreeze the screen so y'all can see what I did. We'll check the work and talk about it. Let's see if y'all were able to get one or both of them real fast. Okay. So here, y'all stop talking, please. Okay, so the first one, okay, it's already set up for quadratic form trinomial factoring. Okay, it's sine squared, sine constant. Okay, The only factors of 2 are 2 and 1. So I know that this is going to factor to 2 sine x and sine x. The only factors of 1 are 1 and 1. So the only thing I really need to think about here is which one gets the positive and which one gets the negative, because I know they have to be opposite signs to multiply to a negative, right? Now, it's not just they themselves, those factors add to the -1 in the middle, okay? They have to be multiplied. Outer functions and the inner functions have to be multiplied. Okay, so you can see those lines, those curves I drew here. So the 2 is going to get multiplied by this one, so that becomes -2 sine of x. This becomes +1 sine of x. And then they're added together to give you that middle term, -1 sine of x. That's how I knew which one was supposed to be positive, which one was supposed to be negative. Are y'all okay with that step? Now, some people in my other classes were not getting this factoring by guess and check that I was doing. It did not make sense to them. You do not have to do it that way. So I'm going to pull up how I did it in another class. I just had them do it by showing grouping. Let me find the right page real fast. Here. Okay, so they were not getting this. So I was like, okay, let's rethink this. Think of this right here. 2 sine squared of x minus sine of x minus 1. Replace sine of x with just x. So that'd be 2x squared minus x minus 1, right? So you can think of it like this, just a regular old trinomial, quadratic. And you can do your grouping method. Okay, you can do your a times c is -2, b is -1. What multiplies to -2 adds to -1 would be -2 and +1. And then you substitute that for the middle term, create your groups, GCF each group, and have your factors. Just realize that now the x, you got to put sine x back in there. So it's sine of x minus 1 and 2 sine of x plus 1. And that's what we got doing guess and check, right? Yeah. So if you need to do that scratch work off to the side like this, that's fine. You can do that and then put it back in terms with sine or cosine or tangent, whatever trig function is there. Okay, whatever is easier for you to understand. Okay, now once I had it factored, I split and solve. So when I solve 2 sine of x plus 1 equals 0, subtract the 1, divide the 2. So where is sine? -1/2. Okay, sine is 1/2 at the pi6th reference angle, and sine is negative in quadrants 3 and 4. So it's the pi6th angle from quadrants 3 and 4. On this factor, I just have to add the 1. Where is sine 1? Remember, sine is the y value. It's 1 right here at the top of your unit circle. That's at pi halves. So 3 solutions for that one. Does that make sense? A little bit? Okay. Now the one on the right was not factoring. Okay, sine squared of x is the only trig term there. Okay, so I can just move my constant, add the 3 over, divide out the 4, the coefficient. Okay, so I think a lot of people are maybe able to get to that step where you have sine squared of x equal to 3/4. Okay, you have to remember to get rid of the squared, the opposite operation is square root. So I square root both sides. And then you have to remember, I think this is probably what most people would mess up on. Even if you remembered to take the square root, a lot of people would miss this. When you take the square root, you have to put a plus or minus. Okay, so the fact that there's a plus or minus there means that we're going to have an answer in all 4 quadrants in this case, because this is not, it's not a quadrant angle. I know it's not on an axis, it's in one of the quadrants. And because of that plus or minus, all 4 quadrants. Remember, when you square root a fraction, square root of the numerator, square root of the denominator. Where is sine square root of 3/2? That's at the pi-thirds reference angle. So it's the pi-thirds angle from all 4 quadrants. Feel okay about that one? Okay, so that's it for that supplemental page of notes that I gave you yesterday. Now, I also, in the original Unit 3 notes packet that I gave you, there is a Part 7 notes page, okay? It's still in that packet, and this is what it looks like. Okay, so in your notes packet, this page is back there. Remember, we changed out the original Part 6 and Part 8. We said we're not going to cover those. You could take them out if you wanted. We were just focusing on solving trig equations. Okay, so this page is still in there. Okay, I'm going to make a video going over this. It's just one page, front and back. So this would be a really good way if you still feel like you're struggling understanding some of this. There's 6 examples here in the notes packet that you have not done yet. So you could do these 6, and then I'll post the key, I'll post the completed PDF, and you can check them. And then if you got them wrong, you can then go watch the video and hear the explanation and see me work it step by step. Okay, so that's like an additional resource that I'll post on It's Learning if you need some additional practice. Okay, this is not a grade. You do not have to go back to the notes packet and fill this in, but it would be a good way to prepare for your quiz tomorrow. And because the quiz is open note, if you have completed in your notes packet, and that's more for you to look at, more for you to use, right? Okay, so I would recommend trying these 6 in the packet and then checking them later this evening, okay, before you come, at some point before you come to class tomorrow. So you have them to use on the quiz tomorrow. If you do not have a complete unit circle, if you have lost yours or thrown away for some odd reason, I don't know why you would do that. I told you would be doing trig for a long time. But if you don't have your completed unit circle, that blue paper we did in Unit 1, okay? I told you to hang on to it. There are blank ones left over there in the hanging folders. Or you can find it a blank one online and print it from home if you want. Okay, I would get it filled in before class tomorrow because again, you get to use it if you have it on the quiz. You don't have your complete unit circle. I'm not giving you one. Okay, that's something you should have in your notes. All right. Now there is a new Delta Math. That is the grade for this practice. It's practicing solving trig equations. Okay, so you can work on the Delta Math or you can work on those additional 6 examples, whichever you prefer right now. But you have the rest of class to work on that. The Delta Math is not due until Monday by 11:59 p.m. Okay, so you have a couple days and the weekend still. All right.